In this tutorial, we're going to take a look at function notation, f of x, and combinations of functions. So we'll take a look at how to evaluate in function notation, and then we'll just take a look at adding, subtracting, and taking the composition of two functions. There is more in-depth information out there, but at this point in our class, that's all we're going to cover. Also, some of these examples may be slightly different from the problems in your textbook, maybe a little bit harder or just a little different. So just be aware of that. Function notation, f of x is read f of x, or the function of x. And the cool thing about function notation is it's really simple to write what we want to evaluate for. So if we want to evaluate when x is 2, we just write f of 2. So f of x is kind of like the y variable that we're used to, and the x is our x, but if we want to show that we want to evaluate at 2, we just write f of 2. So this is pretty simple. We just substitute in 2 for x. So we have 2 times 2 squared plus 3 divided by 2 squared. So 2 squared is 4 times 2 is 8. 8 plus 3. 2 squared on the bottom is 4, so I have 11/4. And I'll just keep that fraction. On the second one, we want to evaluate when x is 0. I'm going to do this one in my head. When x is 0, this is whole 0, so I have 3 on the top. And I get 0 on the bottom. That should be ringing an alarm bell. We cannot divide by 0. It's undefined. Okay, the next one. This one actually has a variable. In fact, you're going to see some problems like this in your homework where you're just going to substitute in a different variable. In this case, the variable is quite similar. It's just a negative x. So every time we see an x, we put a negative x. So 2 times negative x squared plus 3 all over negative x squared. Now, in this function, does it really even make a difference if we put a negative x instead of an x? Well, negative x times negative x will still be positive x squared. It really doesn't matter. So we're back to the original function anyway. Because if we were to simplify those negatives after we square them, they will become positive again. Letter D, f of x minus 2. So now every time we see an x, we're going to substitute in x minus 2. So we get 2 times x minus 2 squared plus 3 all over x minus 2 squared. And you're not really going to see any of these in your textbook, so I'm not going to bother simplifying it, but just note that if we were simplifying x minus 2 squared, we're actually going to have to double distribute or multiply x minus 2 times x minus 2, FOIL it out if that's the phrase you use. So it's a little bit more challenging. We haven't done those quite yet this year. Number 2, we have a function that has 2 parts. The first part of the function is 2x plus 5, but this is only used when x is less than 0. The second part of the function is the square root of x plus 1, and this is only used when x's are greater or equal to 0. So we have to pay attention. This is the domain. We need to know which part of the function to use. This is actually called a piecewise function. So A, g of 0. So we want to evaluate when x is 0. We want to use the bottom one. So I have square root of 0 plus 1, square root of 1, which equals positive or negative 1. G of 3. So that's less than 0. I still want to use the bottom one. Square root of 3 plus 1 equals the square root of 4, which equals plus or minus 2. And evaluate when x is negative 3. Well, I need to use the top one this time because x is less than 0. So I get 2 times negative 3 plus 5. 2 times negative 3 is negative 6 plus 5 equals negative 11. So that's how to easily evaluate in function notation. So that's what this all means. Looking through the examples in your textbook, it looks like they give you two functions to work with, and you will be using those same two functions for all of the problems. So look carefully. So when you see number 1, it might just look like this. So you need to go back and find the function that's labeled g of x or f of x or whatever. Okay, now let's take a look at combining functions by adding. These are pretty simple. All we do is we add f of x to g of x. So we say 1/3 x plus, and I'm going to put this in parentheses because I'm adding the whole entire thing. And it's easy to see that this is my first function being added to my second function. I don't have anything to distribute, so I can go ahead and drop those. 1/3 x minus x plus 4. And I'm going to kind of write in, this is a 3/3. So when I simplify, I have 1/3 x minus 3/3 x. So I'm going to get negative 2/3 x plus 4. It's my resulting function. Now find f plus g of negative 1. So after we combine them by adding, we want to evaluate now for x. So I have negative 2/3 times negative 1 plus 4. That becomes positive, so I'm going to have 4 2/3 as my final answer. So a simplifying strategy for addition is to combine your like terms if possible. Easy peasy. All right, let's do some subtraction. We're going to subtract the functions f minus g. Now, order does matter, so make sure you list your f function first. So the function of x is x squared minus 1/2. And I'm going to subtract g of x, so I'm going to subtract the entire function. Use a parenthesis there. Okay, this is important because I see that I'm going to distribute this minus or this negative. So let's rewrite and distribute x squared minus 1/2 plus 3x squared plus 1. I distributed that to both terms. Now let's combine our like terms. I have a 1x squared and a 3x squared. That's 4x squared. And a minus 1/2 and a plus 1 becomes plus 1/2. That's my answer. Now I want to find f minus g of 5. So I want to substitute it in at 5. 4 times 5 squared plus 1/2. So 5 squared is 25 times 4 is 100. So I have 100 and 1/2. So simplifying strategy for subtraction. Don't forget to distribute the subtraction sign. Use a parenthesis. Then combine your like terms when possible. Again, it's not difficult. Just beware. It's easy to miss a negative sign and get the problem wrong. Okay, composition of functions. This is probably more tricky than it really looks. Composition of functions, f of g of x, or we can write it as f of g of x. This does not mean multiply. It's just the way we notate it. I actually prefer this first method of notating it because it really explains what we're doing. When you find the composition of two functions, the entire inner or second function, so this would be the inner function, g of x, that would be the second function we're talking about. So this entire inner function takes the place of the variable in the outer or first function. So we're going to plug in the entire function of g of x into x of the f of x function. Yeah, it sounds more complicated than it is. So then we simplify and do as much as we can by distributing and combining terms. So let's take a look. Find f of g of x when f of x is 2x plus 1 and g of x is x squared minus 5x plus 1. So g of x is my inner. So I'm going to take the g of x and I'm going to plug it in to the x of my f of x function. So I have, f of g of x equals 2 times x squared minus 5x plus 1. So 2x plus 1. So g of x took the place of x. So now we just simplify this by distributing 2x squared minus 10x plus 2 plus 1 at the end. Combine my like terms, 2x squared minus 10x plus 3. And I am done. Oh, can't see that, can you? Sorry about that. Move this up. So just to go over it again, I distributed here and got this, combined my 2 plus 1, and finished it off. Example 2. Is f of g of x the same as g of f of x? Well, we should probably solve these two problems. We'll call this problem A, we'll call this problem B. If they match, we know they're the same. If they don't, we know that they aren't the same. So f of g of x puts the g of x in the f function. So I'm going to get f of g of x becomes 5 times, so x, I'm replacing it with the g of x, minus 3. Simplify that. 5 times 3 is 15. X squared minus 3. Not too bad. So the second one is g of f of x. So let's start with the g function. 3, I'm to my x, so I got to put all of my f of x in there. So 5x minus 3 squared. So what does this mean? It really means 3 times 5x minus 3 times 5x minus 3. And again, we haven't really done this, but I will finish this problem off. You probably remember it from Algebra 1. So I'm going to do this part first. I have 3 times 25x squared minus 15x minus 15x plus 9. And then I have to distribute the 3 to everybody. So 75x squared. This becomes minus 30x. So I'm going to put minus 90x's plus 27. I don't think they're quite the same. They're quite different. So order does matter. Watch out how they have listed the composition of your function. Make sure you're doing it in the correct order. So they are not the same. So you may be thinking, what is the point of this and why do I even care? Yeah, it's just kind of fun, but no, there really is a point and useful ways that we do use this. So what I want you to do is complete the assignment, and then I want you to complete these problems. You're probably going shopping now. It's almost Christmas, and you might be trying to get multiple discounts. So composition of functions kind of goes really nicely with discounts. So take a look and see if you can prove some of these and answer the questions. All right, I will see you on Tuesday, and please try to have that finished for then.